The night sky held its breath. Out beyond the thin shimmer of the Earth's atmosphere, past the quiet drift of satellites and the slow migration of dust, a single point of light moved with unsettling precision. To the telescopes that captured it, the glow appeared soft at first, as if diffused by distance or folded into the darkness by sheer indifference. But each frame revealed the truth more clearly, a sphere perfectly smooth, unnervingly coherent, radiating a deep green luminosity that bled into the cold void around it. Not a comet's frantic spray, not a fragmenting snowball from the Oort cloud. Something else. Something that seemed to know exactly how it wished to appear. The orb hung in the sky like a signal trapped in transit, neither pulsing nor flickering, steady as a lantern carried through an ancient forest. Its light refused to fade, and its edges did not ripple with the familiar turbulence of dust or ice shedding into space. Astronomers would later speak softly of that stillness, of the way the object seemed to push against the instinctive expectation that nature must be messy, that motion must leave scars, that anything falling toward the sun must pay the price in vapour and debris. On November 10th they expected chaos. A comet emerging from perihelion should be wounded bleeding vapour into the void. Instead, the object surfaced from behind the sun, in a form so immaculate it felt like a contradiction. A perfect orb, smooth as polished glass, drifting without drifting, moving but not meandering, illuminated but not burning, present but without explanation. The night it appeared, amateur astronomers across the globe caught their breath. They had no script to follow, no prepared metaphor for what it resembled. The sphere's glow felt almost intentioned, like a single sustained note from an instrument that should not exist. It cast no tale, bore no trace of the chaos it had survived, and looked for all the world as though it belonged more to geometry than to the long tradition of wandering ice. What unfolded across those hours was not the discovery of an anomaly, but the quiet unravelling of certainty. Something had emerged from the sun's blinding veil, wearing a shape too deliberate for randomness. Yet it showed none of the mechanisms, none of the survival instincts, none of the damage that such a journey should inflict. It was as though the object had stepped into sunlight, paused, and chosen to become spherical, chosen to simplify itself into something the universe was not prepared to categorize. Astronomers watched the unchanged contour frame after frame, no smearing, no dust plume, no rotational blur. Even as it cut through the dark with increasing brightness, the orb remained utterly smooth, as if etched from a rulebook that had never belonged to comets at all. It was not a transformation that drifted into place over months. It was sudden, decisive, and timed with the object's disappearance behind the sun, a blackout moment when no instrument on Earth could witness what occurred. In the quiet aftermath, the cosmos felt changed. The laws that normally cradle celestial bodies seemed momentarily unsure. The orb moved with purpose, neither fragile nor chaotic, held in a silence that resisted interpretation. For the first time, observers felt the unsettling sense that they were not watching a natural fragment of interstellar debris, but something drifting through the solar system, with a story written far deeper than ice and dust. The mystery began not with a signal, not with a radio pulse or a metallic shard, but with the simple defiance of a shape. A sphere gliding where a comet should have been refusing to unravel, refusing to age, refusing to obey the patterns carved into the history of the wandering light. And beneath that refusal, an unspoken implication settled like frost on glass. Objects from interstellar space are supposed to drift. This one did not. The first witnesses stood not beneath domes of steel or glass, but beside small telescopes pitched against the wind. In Wales, where the November cold settles early and the sky opens in brief fragile windows, an amateur astronomer named Gareth Talbot leaned over an aging mount and listened to the quiet hum of tracking gears. He had been imaging the predicted path of the object known as through Atlas, expecting nothing more dramatic than a faint blur, another interstellar wanderer passing briefly through humanity's flickering attention. But when his stacked exposures resolved on the screen, he froze. The light was wrong. The shape was wrong. Everything was wrong. Not a teardrop. Not a ragged, dust-blurred smear. The nucleus did not show the familiar bleeding glow of a comet shedding its past. Instead, a flawless circle burned green against the void, its edges crisp, its surface brightness eerily uniform. Gareth checked his filters, reset his guiding, reshot the sequence. And still the orb remained serene and impenetrable, as though it had always been meant to be seen that way, and the sky was finally ready to reveal it. His raw frames time-stamped just after midnight hit the Cloudy Nights forum before sunrise. No commentary, no speculation, just the data, FITS files, exposure logs, calibration steps. Within minutes, observers across Europe were downloading the frames, stretching the contrast and blinking them against their own archives. By dawn, Toronto posted corroborating images. Osaka followed. Then Madrid. The same sphere captured by different sensors under different skies using different rigs. No smear, no tail, no coma. The universe had spoken in a shape that left no room for coincidence. It was the amateurs who anchored the truth first, not the institutions. Their data arrived unfiltered, untouched by committee free of the slow hesitations that accompany official channels. And as more frames appeared, the conversation sharpened. Exposure times varied. Pixel scales shifted, but nothing softened the sphere's outline or dimmed the stubborn green that pulsed against the blackness. If the image were an artifact, an optical glitch, a stacked error, a faulty calibration, those differences would have fractured the illusion. Instead, they reinforced the reality. A telescope in Maine posted a 20-minute sequence. The orb maintained its structure through each frame, unwavering, unchanged. Surface brightness uniform within 3%. The object held its shape even as Earth rotated beneath it, and sensor noise crept into the edges of the stacks. That level of consistency is not the behavior of a natural comet in the throes of solar heating. Comets breathe, they shed, they warp under the assault of light. But the orb showed none of that. Its silence was total. By midday, observatories were quietly confirming what amateurs had already proven. The transformation was real. The object had emerged from the solar blackout altered in a way no known comet had ever been recorded to change. Yet the first response from official institutions was not awe, it was hesitation. Data was reviewed behind closed doors. Statements were delayed. Emails went unanswered. The sphere had not only defied the textbooks, it had outpaced the protocols built to contain the unexpected. Meanwhile, the amateur community continued its relentless documentation. Some observers recalibrated their rigs to remove any suspicion of camera-induced symmetry. Others reprocessed their FITS stacks at varying noise thresholds to test the robustness of the sphere's outline. It did not break. The data refused to yield to mundane explanation. Multiple observers aligned their images to trace the sphere's centroid drift, expecting a blur if the object rotated irregularly. It didn't. The globe held its perfection frame after frame as if rotation meant nothing at all. This was not a moment of global panic. It was a moment of quiet defiance where the independent eyes of the sky pushed back against the slow machinery of institutional certainty. The amateurs moved fast, comparing atmospheric conditions, sharing calibration lamps, cross-matching timestamps. Their raw files aligned too well to dismiss. Their measurements showed no jet activity, no expanding halo, no dust stream. The comet that had once behaved like a messy boiling wanderer had become something else entirely. In a small observatory on the outskirts of Madrid, a retired engineer named Silvia Morales approached the phenomenon with the same discipline she once used in aerospace diagnostics. She mapped the object's intensity profile, expecting the usual asymmetry caused by outgassing patterns. Instead, she found a radial uniformity so precise it resembled manufactured symmetry, more than natural evolution. Her private notes, later shared anonymously on a Spanish forum, captured the quiet shock of the moment. It appears constructed, not formed. Yet no one dared say such words aloud, not in official spaces, not in peer-reviewed language. The sphere might have been perfect, but science demands restraint before wonder, and so the amateurs, despite their astonishment, kept their discussions grounded in the language of anomaly, unusual thermal behavior, atypical morphology, non-standard coma collapse. They obeyed the rules of cautious interpretation, even as the object itself seemed to mock those rules. Across the ocean in Toronto, a physics student named Amir aligned his sequence of exposures and noticed something subtle, but disturbing. The sphere did not exhibit the slight edge softening expected from atmospheric turbulence. Even through Earth's shifting air, the orb appeared unnervingly stable, as if it held its own focus, as if its surface rejected distortion. Emir triple-checked his seeing conditions: clear, dry, uniform. Yet even under optimal skies, comets do not carve themselves so sharply into the night. He posted the question that would echo through every forum thread that day. Why isn't it drifting? Natural bodies drift not only in their trajectory but in their appearance. They evolve, their forms shift, their jets pulse, their halos expand and shear away. Drift is nature's signature. But this object had abandoned that signature altogether. Its shape suggested intention. Its colour hinted at chemistry that refused to disperse. And its stillness whispered a truth that humanity was not ready to hear. By the second night, hundreds of images from across the world had converged into a single, undeniable narrative. The sphere was not an error, not a misreading, not a trick of the lens. It was a transformation witnessed by dozens of independent eyes, documented across continents and anchored in raw data that no institution could easily dismiss. The first eyes on the impossible belonged not to those with funding, nor to those with committees and laboratories, but to those who stood alone in the cold, pointing small telescopes at the sky, because they loved the quiet patience of watching things move through darkness. And it was they, not the agencies, who preserved the truth of the moment before it vanished into classification, caution, and controlled narratives. In the end, the discovery did not begin with authority. It began with individuals staring upward, and the sphere glowing alone in the void stared back without drifting, without breathing, without decay, as though it had been waiting for them. The images from November did not merely surprise astronomers, they fractured the continuity of an object they believed they already understood. Because months earlier, 3i Atlas had been astonishing, in precisely the opposite way it was ordinary. Comfortingly, reassuringly, even beautifully ordinary. A standard cometary traveller whose every feature aligned with everything physics textbooks promised a comet should be. And that baseline built by Hubble stereo ground-based observatories and countless amateur eyes became the quiet scaffold against which the later mystery towered. In July, when Hubble captured its first high-resolution images, 3i Atlas looked alive with the messy exuberance of a visitor, finally feeling sunlight after eons in interstellar cold. A bright nucleus glowed at its centre, a condensed heart wrapped in vapour and dust. Around it, a chaotic spherical haze stretched outward the coma. Sunlight played across it, igniting jets of sublimating ice that flared unpredictably from the nucleus. The tail streamed behind like a dissolving memory, a filament of dust carried by solar wind. Every instrument that looked upon it agreed. Hubble's ultraviolet-sensitive cameras caught faint jets flickering at different angles. This stereo spacecraft designed to study solar activity, not interstellar debris, logged a trailing haze consistent with volatile compounds boiling away. Even the amateurs in July and August captured its textbook features: the broad, uneven glow, the asymmetrical brightening as it rotated, the faint anti-tail sometimes visible when dust drifted toward the sun instead of away from it. Nothing about 3i Atlas's early behaviour asked for attention. It followed the solar script with almost theatrical obedience. A comet under stress, a wanderer encountering heat, a fragile object shedding its past frame by frame. The brightness curve matched predictions. Its colour green from diatomic carbon fluorescing under sunlight was nothing unusual. Its orbital trajectory fit cleanly within the gravitational models used by JPL's Horizon system. The astrometric data plotted like every other comet that has ever passed through the inner solar system. No anomalies, no surprises. What matters most in this early chapter is how profoundly normal it all seemed. Scientists took comfort in that normalcy. Here was an interstellar visitor whose behaviour could be explained through the familiar vocabulary of ice dust and sunlight. Even when the object spun up slightly detected through subtle shifts in brightness, no one raised an eyebrow. Comets do that. They twist, they wobble, they breathe. And so the world of astronomy fell into a gentle rhythm. Night after night, observatories logged its motion. Teams analysing its composition noted the expected molecular signatures. Stereo catalogued the jets as they sputtered and reformed. A few researchers debated whether the tail's faint kink suggested uneven heating. Others argued it was simply observational bias. But these were mundane questions, the kind that fill conference sessions and departmental emails. No one suspected that the comet's apparent frailty was merely a first act. No one imagined that the flaring jets, the shedding dust, the blooming coma, all the hallmarks of a natural traveller would vanish so abruptly that the object emerging later would resemble a different species of visitor altogether. If anything, the early observations were comforting precisely because they left no room for mystery. In the quiet summer before the blackout, 3i Atlas looked predictable. Then came perihelion. the moment when comets usually unleash the height of their volatility, the point where sunlight breaks apart surface layers, where tails grow wild, where jet activity spikes. And as the object swung closer to the Sun, astronomers prepared to observe what they assumed would be the peak of its instability, a comet pushed to the edge of its endurance. But that was not what happened. Instead, as the comet raced into the solar glare, it simply disappeared. Instruments lost their grip on it. Its signal drowned in the blinding torrents of solar radiation. Observers waited for it to re-emerge, battered, dishevelled, perhaps fragmented. Some even speculated that the stress of heating might split it, as had happened to other interstellar comets before. Disintegration is a frequent epilogue for small, fragile bodies that wander too near the Sun. Many expected that 3I Atlas would follow that familiar arc collapse, fade and dissolve into a brief sad whisper of dust. But 3I Atlas did not dissolve. It returned perfected. The contrast between the object's early chaotic form and its later transformation was not philosophical, it was physical. It was measurable. It was undeniable. Comparing the pre-perihelion data to the post-blackout images felt like holding two portraits of a single traveller painted by different laws of nature. One alive with messy entropy, the other carved from precision. A comet's coma does not simply vanish. Its jets do not cease without explanation. Its tail does not collapse into nothingness overnight while preserving the structure of its core. And no comet in the historical record, none has ever emerged from perihelion smoother, more uniform, or more intact than it entered. Nature does not hone a comet into a sphere, yet that is precisely the shape astronomers stared at in disbelief. The shape that held firm in every amateur's raw FITS file. The shape HiRISE later confirmed at startling resolution. The shape that defied the very baseline established by earlier observations, and so the scientific shock of what followed was not just rooted in novelty but in betrayal. The comet had broken the script. It had abandoned all the evidence of its former self. It had shredded the continuity the universe usually respects. For reasons no one could yet name, the object had forgotten what it once was, and in that forgetting the mystery had only just begun. Before the sphere's emergence ignited a global shiver of disbelief, a quieter storm brewed behind sealed conference room doors, dimly lit laboratories, and the encrypted networks threading NASA's inner architecture. For while amateurs had captured the orb's impossible perfection, in the open light of citizen science, the clearest images, the ones that should have guided the world toward understanding, were sitting in silent confinement, sealed not by mystery but by bureaucracy. Weeks earlier, in early October, the Mars Reconnaissance Orbiter had executed an observational maneuver that would later become the centre of a heated, spiralling controversy. HiRISE. The razor-sharp camera orbiting Mars, designed to capture boulder fields and dust devils, had been turned toward a speck hurtling through interplanetary space. A brief window, barely 3 seconds of exposure time, had been calculated with almost surgical precision. One chance, one shot, one unrepeatable moment as 3I Atlas skimmed past Mars close enough for the orbiter to capture details no other active mission could match. And then nothing. The images did not appear on the usual public database. No press release accompanied them. For a mission accustomed to releasing Martian landscapes within days, the absence rang louder than any announcement could have. Engineers who routinely handled the data could see that something unusual had occurred. The files existed. They had been downlinked, mirrored, catalogued, but they had not passed through the standard pipeline that distributes raw frames to researchers and public repositories alike. At first, the silence was explained away with technical jargon. Calibration delays, shutdown protocols due to funding turbulence, internal review steps that required additional signatures. But beneath those layers of rationalization lay the simple, unavoidable truth: the images were being held back. Scientists within the HiRISE team followed protocol. They drafted memos, reviewed data integrity, and waited for clearance. Their internal logs noted the image quality, exceptional resolution, stable signal exposure curves performing near optimal thresholds. Some reviewers commented quietly to colleagues that the frames showed a cohesion in the comet's structure that felt unusual, even unsettling. But this was spoken only in whispers. Data, not interpretation, was their task. The weeks ticked by. Outside NASA, the amateur community chronicled the sphere's transformation with relentless transparency. Raw FITS data crossed continents. Individuals aligned timestamps and overlaid exposures to reveal patterns professional scientists could no longer ignore. The orb's stillness, its symmetry, its inexplicable refusal to behave like debris, these became truths too public to suppress. Inside NASA, however, the question was not merely what the object was, but why the high-rise images were being slowed to a crawl. China's Tianwen-1 mission had released its Mars flyby frames of the same object within days. The contrast was stark. Two nations had captured an unprecedented interstellar visitor from similar vantage points. One nation shared without hesitation. The other stood silent behind the layers of paperwork and procedural frost. The pressure built slowly at first, then with gathering force. Astronomers, journalists, and congressional aides began to ask what exactly was hiding in the high-rise data that made NASA hesitate. Yet the agency continued to answer with caution, if it answered at all. Hidden within the classified circulation channels, the images now took on a symbolic weight they had never been expected to carry. For the few who had seen them internally, a pattern was becoming clear. The object did not appear ragged, volatile, or wounded from its solar encounter. It appeared stable, smoother than anticipated, more uniform than any natural comet should have been at that stage. Still the public waited and waited. Finally, a political force intervened. With mounting concern, Representative Anna Paulina Luna's office issued a formal demand: explain the 6-week blackout on the MRO data, or prepare to do so before the full glare of public scrutiny. It was a rare collision of legislative authority and astrophysical curiosity, and its impact was immediate. NASA agreed to a closed-door briefing. Those who attended described the atmosphere not as hostile, but as weighted, as though everyone in the room shared an unspoken knowledge that the images would raise more questions than they answered. NASA representatives cited data validation protocols, solar conjunction, complications, safety considerations for mission hardware, every justification coded in the familiar tone of cautious bureaucratic neutrality. But even as they spoke, a truth lingered beneath their words. The blackout had not been purely procedural, and so, under pressure, NASA released the images, or rather they released processed versions, cleaned, corrected, compressed, accompanied by technical notes that obscured as much as they revealed. The raw FITS files, the telemetry logs, the chain of custody metadata remained sealed behind Freedom of Information Act channels, known to move slower than planets. For the scientific community, it was a moment of whiplash. The clearest images ever taken of an interstellar visitor had been withheld during the exact period when their clarity mattered most. Even worse, those who studied the released frames detected discrepancies, subtle differences in contrast, unexpected noise behavior and oddities that hinted at deeper layers of processing or perhaps deeper layers of complexity in the object itself. If the images had been mundane, they would never have been delayed. But they had not been mundane. HiRISE had captured a structure immaculate enough to challenge the assumptions held since July. Perfect curvature, uniform brightness, no debris, no jets, no sign of rotational blurring. A silence of structure so complete that it felt intentional. Not a comet behaving strangely, a comet behaving as though it had learned not to decay. And behind this revelation a second truth loomed larger. The classification of images was not the beginning of secrecy. It was merely the first visible symptom. The orb had emerged from the sun transformed, and the clearest human-made eyes to witness that transformation had long been forbidden to blink. When the orb vanished behind the sun, the sky fell silent in a way that felt almost deliberate. For weeks the object's path had been meticulously charted frame by frame, coordinate by coordinate, until its light finally slipped into the blinding domain of the solar horizon. All objects approaching perihelion experience this disappearance. It is a simple consequence of geometry and luminosity. Yet this time the blackout carried a weight that no ordinary solar conjunction had ever borne. Because unlike the thousands of comets whose signatures dissolve harmlessly into the sun's glare each year, this one would not re-emerge in any recognizable form. On October 29th, Atlas plunged into the most hostile region of its trajectory. At that moment the sun filled its entire forward sky, a furnace of radiation so intense that even our most resilient instruments recoil from its brilliance. No optical telescope on Earth can penetrate those wavelengths. No space-based observatory positioned at L1 can survive the saturation. Only solar monitoring spacecraft blind to the kind of detail astronomers needed could even attempt to track its ghostly silhouette. For a moment the object became unmeasurable, unseen, unsensed. It was as if the cosmos had folded a curtain across its stage. What happened during those lost hours and days would become the fault line dividing what came before from everything that followed. Because when the object finally reappeared on the far side of the Sun, it was no longer the fractured, volatile, chaotic wanderer recorded in July. Something had taken its place, something smooth, unified, inexplicably symmetrical. A sphere with the kind of perfection that nature typically opposes. The blackout itself was nothing extraordinary, but the transformation that followed was. During solar conjunction, the Earth-Sun object geometry places the visitor in a position where it cannot be observed from the ground or from any Earth-aligned orbital assets. Comets have been known to shatter during this interval. Some split into fragments, others evaporate entirely, and many experience violent outgassing that flares in dramatic plumes. But those events always leave evidence distinctive signatures in their brightness curves, tails laden with debris or rotational asymmetry that observers can measure within hours of reappearance. This object returned with none of those scars. From the moment it re-entered the visible sky, its form was singular. No coma, no jets, no debris, no tail. What emerged was not a survivor. It was a replacement. Amateur astronomers were the first to notice it, but professional teams soon confirmed the object no longer behaved like a body shaped by nature's chaos. Its surface brightness did not fluctuate with rotation. Its outline did not distort as the solar wind pressed against it. There was no indication of mass loss, no sublimating gases, no motion-driven turbulence. Instead, the sphere appeared as if sculpted, not eroded, aligned, not decaying. The Sun had become not a destroyer but a veil, and behind that veil something had shifted, yet the deeper shock came from the timing. Perihelion is the moment at which even the slightest force thermal, chemical, mechanical produces the largest possible change in an object's trajectory. Physics amplifies everything there. A single outgassing jet, even a minor one, can twist a comet's future path across millions of kilometers. If the object possessed any dormant mechanism, natural or otherwise, perihelion was precisely when that mechanism would be most effective. It is also by cosmic coincidence the moment when Earth-based observation is most compromised. For those who distrust coincidence, the blackout window became a focal point, not because it proved intention, but because it erased the continuity of evidence. There is no record of what happened during those hours. No images, no spectra, no photometric curves, only the undeniable before and the incomprehensible after. In July, the visitor was a comet by every metric. In November, it was not. And what lay between those moments was a silence deeper than the night sky itself. Some suggested that the Sun's radiation could have compacted the object's shell, solidifying it into an unlikely but still natural configuration. Others proposed that its icy fragments had melted away cleanly, leaving behind a dense, metal-rich core. Yet neither explanation addressed the central paradox. Even metal-rich objects do not become perfect spheres under heating. They melt fragment-fracture. They do not polish themselves into geometric clarity. Still others suggested rotational smoothing, a process in which rapid spin reshapes a body. But rotational smoothing requires time debris dispersal and visible distortion. None of these appeared in the post-perihelion imagery, so the blackout grew heavier with interpretation. Perhaps nothing unusual had happened in the solar glare. Perhaps everything unusual had. Astronomers debated quietly, careful not to imply conclusions the data could not support. Yet even the most cautious hesitated when forced to reconcile the orb's structural perfection with the chaos it had once embodied. They spoke in the language of unknowns, unexplained morphological transition, non-standard coma-collapse anomalous symmetry, polite terms for a transformation that seemed almost surgical. In their silence, the object moved onward unchanged by scrutiny. It glided from the Sun with a serenity that defied the violence of its passage, as if perihelion had not been an ordeal but an initiation. And the cosmos, which so rarely offers decisive moments, had offered one a deliberate absence of data precisely where clarity mattered most. The blackout was not the mystery, the blackout was the boundary, a divide between what humanity could explain and what it could only watch unfold. Long before the sphere's shape became the focal point of late-night debates and quiet scientific unease, there was a subtler anomaly threading its way through the observational record. One so understated at first that most teams brushed it aside as noise, a tiny discrepancy, a fractional misalignment, a drift so small it hid within the margins of probability. And yet this was the anomaly that would ultimately fracture the foundation beneath the sphere's calm perfection. It began as many astronomical revelations do with the math. Astronomy is not simply the study of distant light. It is the discipline of prediction, of knowing where something should be long before it arrives there. Comets follow this principle faithfully. Their paths may wobble without gassing. Their brightness may fluctuate, but their motion bends obediently to gravity. The equations are old solid and deeply trusted, but as thousands of astrometric measurements of 3i Atlas accumulated coordinates pinned to timestamps, each entry carefully logged across observatories, a quiet deviation began to take shape. A predicted position, an observed one, and the two no longer matched. At first, the offsets were negligible tenths of an arcsecond well within what might be expected from inconsistent weather or minor calibration differences, but with each passing week the drift grew, not chaotically as noise does, but systematically. A steady push, a consistent nudge, a pattern that refused to scatter. By September, analysts at the Jet Propulsion Laboratory began to notice that every orbital solution they computed required an additional parameter, a transverse acceleration term. Known as A2, it is a mathematical placeholder for forces that cannot be explained by gravity alone. Comets sometimes need A2 when jets erupt directionally from their nuclei. Ice sublimates, vents form, and a stream of vapour imparts a tiny measurable thrust. Yet the orbital fits for 3i Atlas demanded an A2 value that made no sense. A force was acting upon the object, a persistent force, a gentle but undeniable push, and yet the images, high-resolution multi-frame, multi-instrument images, showed no jets at all. Harvard's team running their own orbital solutions using an independent covariance matrix saw the same result. No matter how they tuned their assumptions, the non-gravitational acceleration refused to disappear. Even after discarding portions of the dataset, even after stripping measurements from nights with poor seeing, even after excluding frames near solar conjunction, the acceleration persisted. It was real. Even worse, it was coherent. In comets, outgassing forces fluctuate with rotation. When the nucleus spins, jets reposition relative to the Sun, causing irregular pulses of thrust. But the force acting on 3i Atlas showed none of this modulation. It was steady, predictable, almost calm. A comet cannot sustain a fixed directional push unless its jets remain fixed relative to the Sun. But for that to happen, the comet must either not rotate, which contradicted brightness variations earlier in the year, or rotate perfectly in sync with a stable jet geometry, a scenario so improbable it bordered on impossible. Yet here the object was accelerating as cleanly as if following a script. As the deviations grew more pronounced, analysts rechecked their reference stars. They recalibrated their astrometric plates. They even compared clock drift between observatories in case timestamp errors were accumulating subtly. Everything checked out. Gravity alone could not account for the path, and still the sphere in the images offered nothing to explain it. No flares, no dust, no halo growth, no visible ejection of matter, nothing that might generate the missing thrust. The absence became a kind of intellectual vacuum, one that pulled every conversation toward an uncomfortable question scientists are trained to avoid. How does something accelerate without shedding mass? Newton's laws are among the most unyielding pillars of physics. They do not bend, they do not soften. For every action, there must be a reaction. For every change in velocity, something must be expelled, pressed against, pushed from. And in space, with no surfaces to push against thrust, can arise only from shedding mass, or interacting with electromagnetic fields in ways 3i Atlas did not visibly exhibit. But the orbit insisted. A few thousandths of a meter per second squared, tiny, gentle, yet relentless. Enough to shift the object millions of kilometers off its expected course over time. Enough to generate the steadily widening discrepancy the Minor Planet Center quietly annotated in its residual logs. Enough to force computational models to accept a truth the images resisted. Something was pushing the sphere. The contradiction deepened. If the object was shedding matter to produce thrust, the high-rise images should have caught the debris, especially given the camera's unparalleled resolution. Even a fragment the size of a compact car liberated during perihelion would streak noticeably across the background stars in a long exposure. But every pixel of the orb's perimeter held steady. No tails, no jets, no dust storms, no faint haze trailing behind it. A body cannot propel itself without evidence of propulsion. Yet the propulsion was measured, and the evidence was missing. Astronomers coined careful terms for this contradiction: non-correlative mass loss signature, thrust without debris constraint, anomalous acceleration with absent emission. Phrases designed to soften the paradox. But the truth beneath their caution was stark. The laws of motion demanded a force. The sky refused to show where that force came from. And in that gap, in that silence between mathematics and imagery, unease began to form. The kind of unease that lingers long after the equations are solved. Because if a natural body can accelerate without visible cause, then something nature has never demonstrated before is unfolding silently in the dark. But if the force is not natural, then the origin of the acceleration becomes a question far heavier than physics alone can bear. The sphere did not drift. It moved with purpose, and the cosmos was only just beginning to reveal how deeply that purpose ran. The contradiction tightened like a knot as new data poured in. The object was accelerating, and yet nothing in the images, nothing in the light that reached Earth, betrayed the mechanism physics demanded. It was a paradox that grew sharper with every exposure. Because if a comet is pushed forward, it must pay in mass. Dust, vapor, fragments, something. Nature does not give motion freely. But the sphere defied that cosmic accounting. High-Rice's images were the first to make this contradiction uncomfortably explicit. Designed to scrutinize Martian sand grains and frost patterns, the camera possessed acuity far beyond what most deep space instruments could manage. When the object slipped near Mars, even its faint glow was sliced with surgical clarity across the detector. Analysts expected turbulence, ragged edges, uneven brightness, a debris halo expanding like smoke from a fire. But each frame returned one unwavering truth: the orb was intact, unbroken, pristine. When researchers dissected the brightness profile, they found a uniformity that mocked natural processes. Cometary surfaces vary. Dust clouds shift. Jet outflows create uneven light feathering into gradients. But this object showed a radiance almost mathematical in its consistency. No bright spots, no fading patches, nothing to suggest outward motion from its surface. The curve of reflected sunlight traced the same flawless arc across the sphere in every frame. Nature with its rough machinery does not sculpt such precision. From the data, analysts calculated what the object should have looked like if the detected acceleration came from gas jets. Based on models used to explain non-gravitational accelerations in comets, it would have required losing at least 10% of its mass over the course of its journey. A tenth of itself expelled into space. Enough material to form a long, billowing tail. Enough to create a halo so large it would be impossible to miss. Enough to blur the edges of the object into a glowing smear. Yet the edges remained sharp. Some high contrast stacks even suggested they were too sharp, exhibiting a boundary that did not diffuse under solar pressure. That boundary became a point of whispered speculation. Not among amateurs, but among mission scientists reviewing the frames in silence. A boundary that resisted erosion. A surface that seemed to reject sublimation. Whatever the sphere was made of, it did not behave like ice exposed to sunlight. It did not fracture. It did not shed. Instead, it held its shape with a serenity that felt unnatural. Attempts to identify even faint streams of dust yielded nothing. Analysts split the data by wavelength, looking for subtle patterns hidden in the noise thermal dust signatures, micron-level particulates, fossil plumes. The result was a clean void. The sphere emitted only purity, no clutter, no residue. This left researchers in a stalemate between equations and images. The orbit shouted that mass was disappearing. The pictures insisted not a grain of it had been lost. Some scientists explored more exotic explanations. Perhaps the sublimation was occurring symmetrically so that every outgassed particle balanced a counterpart on the opposite side. A beautiful idea, mathematically elegant, physically impossible. Symmetrical sublimation would require a body whose jets aligned with perfect coordination, adjusting instantly to rotation and solar angle. Comets are chaotic structures. Their vents open and close like wounds. Their jets flare unpredictably as pockets of volatile material ignite. But this object had no pockets, no fractures, no scars. Others suggested invisible particles, species of gas too fine to detect escaping in volumes too large to track, yet somehow too gentle to form any visible signature. But such gases, if they existed in quantities required to accelerate a 100-meter object, would glow under solar irradiation. They would fluoresce even if faintly. No such glow appeared. Still others speculated about magnetic forces. Perhaps the object possessed a charged shell interacting with the solar wind. But the sphere exhibited no magnetic signature, no polarization, changes, no brightening consistent with charge exchange. Every natural explanation unravelled under scrutiny. And in that unravelling, the sphere grew stranger still. High-rise data suggested the object was rotating. Slight shifts in brightness hinted at motion. And yet the lack of debris demanded a paradox. Either the sphere was not rotating at all, which contradicted earlier observations, or it was rotating in a way that preserved perfect structural integrity, while somehow preventing the escape of matter. A kind of rotational quietness, a functional stillness married to internal motion. As analysts compared HiRISE with Hubble images, they found themselves staring not at a comet but at a contradiction incarnate. A perfectly shaped object accelerating through the solar system without expending itself. An object that refused to follow the rules of erosion or thermodynamics. Then a new question crept through private discussions softly, hesitantly, as though spoken into a room filled with fragile glass. If it is not shedding mass, then is it being pushed from within? Not by combustion, not by chemical scent, but by a mechanism hidden beneath the smooth, inscrutable exterior, a mechanism buried so deeply in the data that its existence could only be inferred from absence. The sphere gave nothing away, no vents, no seams, no shadows suggestive of structural architecture. Only silence. Perfect silence. Yet its motion spoke loudly. Even without drifting, the orb was moving. Even without shedding mass, it was accelerating. Even without revealing purpose, it was following a path that refused randomness. In the widening gulf between motion and mechanism, the object deepened its mystery. A comet need not explain itself. But whatever this sphere was, it seemed to move with intention. Perihelion is a crucible, a place where the ordinary rules of celestial travel sharpen into something more decisive. Every comet, asteroid, and wandering fragment that dives toward the sun is subjected to the same ancient furnace, a realm where radiation strikes like hammers and heat unravels molecules. Yet for objects in motion, perihelion is more than simply a test of endurance. It is an opportunity, a pivot point, a moment in which even the smallest force can carve an entirely new future. The effect is woven into the heart of orbital mechanics. Physicists call it leverage, though the formal term is the Oberth effect, a principle revealing that energy spent when an object is moving at its fastest yields far more impact than the same energy spent at any other time. For spacecraft, this effect is priceless. A short engine burn at perihelion can do the work of a prolonged burn farther out. The inner solar system amplifies thrust like a lens sharpens light, and so when 3I Atlas hurled itself around the Sun on October 29th, its velocity peaked at more than 130,000 miles per hour. It was the fastest point in its entire journey through our system. If anything were to alter its path, any jet, any burst of energy, any internal mechanism that moment would have magnified the effect beyond proportionality. A tiny nudge becomes a tectonic shift. A whisper of force becomes a signature written millions of miles downrange. Under normal conditions, this amplification does not introduce mystery. Comets erupt during perihelion. Their surfaces fracture under heat-releasing gas jets that spike unpredictably. These jets act as natural thrusters, messy, chaotic ones nudging a comet this way or that. Scientists track these deviations. They model them. They are not anomalies. They are character. But 3I Atlas did not erupt. It emerged from the Sun calmer, smoother, steadier, radiating a geometry that felt almost chosen. And yet the orbital models, those cold, unbiased equations, reported that a significant force had acted during that window. A push. A thrust. Something that changed the comet's path precisely when Earth could not see it. The implication lingered uncomfortably. If the orbital shift occurred during perihelion, then whatever caused it happened when the object was hidden behind the Sun. A blackout of both sight and certainty. Scientists reviewing the data could not deny the tight timing. For weeks before perihelion, the object adhered closely to gravitational predictions. For weeks after emerging, its trajectory was subtly, but unquestionably altered. Something had exerted force during the exact period when observational capabilities were at their weakest. The coincidence was too well aligned. The geometry of the blackout, the mechanics of the orbit, the amplification of perihelion, all converged on a narrow moment when 3I Atlas slipped beyond our instrument's reach. In that place of solar fire, invisible to human eyes, the object changed both its direction and its form, and so researchers returned to the data with growing unease. They reviewed the probabilities. The object had passed near Mars, bending its path in a gravitational brush so precise It resembled a planned trajectory more than a random flyby. Then it threaded close to Venus, then Jupiter. Each encounter took place in the month bracketing perihelion, forming a sequence of alignments that simulations insisted should be rare. But it was the timing of perihelion, a pinhole window where the sun's glare blinds every Earth-based sensor, that elevated those alignments from improbable to unsettling. If anything happened, anything at all, it would leave no direct evidence, only consequences. When the object reappeared, the sphere was not the only new puzzle. Its motion, its silent, persistent acceleration, betrayed a change that could only have been amplified by perihelion's leverage. No natural explanation fit. No known mechanism left the sphere unscarred. Nothing in the archives of cometary behaviour could mirror this transformation. And so astronomers began to contemplate the possibility that the object's interaction with the sun had not been a passive one, that perhaps the sun had not simply illuminated it, but had triggered something within it. A phase change, a structural shift, a release of energy that operated invisibly to our instruments yet carried enough potency to alter the comet's fate. Some speculated about exotic materials, ices that refract heat, inward surfaces that respond to solar flux in unfamiliar ways. Others theorized about internal structures insulated against sublimation, capable of absorbing heat without decay. Still others proposed advanced phase transitions where matter at extreme temperatures reorganizes into stable configurations. But these ideas explained neither the perfect sphere nor the precise timing. Only one fact remained immovable. Perihelion is the universe's amplifier. What little happens there becomes enormous. What is hidden there becomes decisive. And 3i Atlas had used perihelion to become something unprecedented. As the object sailed outward, now a flawless orb, the implications mounted. If natural forces had transformed it, they would have done so randomly, asymmetrically, leaving scars. But the shape was unmarred. The acceleration was smooth. The path deviated as though guided by a force that knew exactly when to act and how to harness the sun's multipliers. Astronomers do not speak of intention lightly. The word carries gravity. It suggests a boundary crossed from physics into meaning, and no one wished to cross it. Yet perihelion had forced their hand, for the sphere to change as it did, and for the acceleration to align so perfectly with the moment of greatest leverage. The transformation could not be dismissed as happenstance. Something happened behind the sun, something hidden, something potent, something that used the mechanics of the universe with an elegance no comet had ever displayed. And as the sphere drifted back into view, unchanged and unblemished, it whispered in its silence. What occurred in the solar furnace was not drift, it was choice. In the quiet rooms where probability is calculated, where simulations run through 1,000 silent nights, scientists found themselves staring at numbers that felt less like statistics and more like an accusation. Because the deeper they dove into the orbital history of 3i Atlas, the clearer one truth became. The path this object carved through the solar system should not have happened, not by chance, not by drift, not by any familiar scattering of interstellar debris. Harvard's computational group was the first to quantify the unease. Using tens of thousands of simulated interstellar visitors, each entering the solar system from random directions with random velocities, they attempted to reproduce the exact corridor 3i Atlas followed. A narrow trench aligned within only a few degrees of the ecliptic plane, a thread passing near Mars, grazing the region of Venus, then drifting near Jupiter's gravitational well. A path that plunged behind the sun during the very moment when it was most likely to alter course undetected. Out of 100,000 simulated objects, only 5 produced anything even remotely similar. 5. Not 5%, not 5 in 1,000, 5 in 100,000. A probability so vanishingly small it carried the faint chill of orchestration. The ecliptic alignment alone strained belief. Interstellar objects should arrive from every direction in space, scattered like pollen on a cosmic wind. The solar system's planetary plane is a thin, fragile slice of order, surrounded by vast, indifferent darkness. Yet 3 Atlas entered almost perfectly aligned with it, as if tracing the same ancient circle, carved by planets, that had existed long before its arrival. Simulations placed the odds of such alignment at roughly 0.2%, 2 in 1,000. But the object did not merely align with the ecliptic. It threaded through gravitational corridors with a precision that felt rehearsed. It passed near planets in a sequence so improbable that even broadening the tolerance parameters, loosening the simulation's criteria, barely improved the results. Whether one used Harvard's model or the European Space Agency's independent replication, the numbers echoed the same eerie verdict. This path should not exist. Astronomers tried to explain it through natural channels. Random chance, they said. A statistical outlier. After all, improbable paths must still occur occasionally. Yet the object's behaviour strained even this reasoning. Because improbable alignment is one thing. Improbable alignment timed with an observational blackout precisely at perihelion, precisely when a trajectory change would be most effective, is something else entirely. Statistical anomalies rarely stack themselves so neatly atop one another. They rarely form sequences. They rarely behave like decisions. Mars was the first waypoint. The object passed at a distance close enough for a subtle gravitational handshake, close enough that the Mars Reconnaissance Orbiter could capture it, had the images not been delayed by weeks of silence. Then Venus, its gravity bending the object's path with delicate influence. Then Jupiter, whose massive presence tugged gently but measurably at the visitor's arc, all in a synchronized procession. It was like watching a stone skip across the surface of a pond, hitting each point not by accident but by design. Physicists at ESA expressed quiet discomfort in their internal notes. One researcher described the alignment as textbook improbable. Another compared it to a dart thrown blindfolded into a stadium, hitting the bullseye of a dartboard hung in the rafters. Nature can throw strange darts, but it does not typically throw precision. The wider scientific community hesitated to state this openly. Words like guidance or intentionality cross boundaries no physicist wishes to breach. Science prefers uncertainty to implication, but probabilities do not soften themselves for fear of interpretation. They do not blink or blush or retreat. They simply stand. And these probabilities were beginning to look like a pattern. The object appeared to move with a strange balance, neither purely ballistic nor purely chaotic, neither drifting like debris nor maneuvering like a spacecraft. Something in between. Something that understood the architecture of the solar system well enough to thread it, yet did so without the signature of conventional propulsion. When the numbers were presented in closed research circles, the conversations grew tense. Some scientists argued that a single improbable orbit proves nothing. Others countered that when improbability aligns with simultaneous morphological anomalies, invisible acceleration, and a perfect geometric transformation, it becomes less like a coincidence and more like a clue. Even those who rejected speculation could not ignore the math. This was not the path of an object thrown carelessly through the galaxy. This was the path of something that moved as though aware of the lanes carved by planetary gravity. Something that behaved as if using those lanes. Whether by nature or something more deliberate, the orbit traced a message written not in symbols but in statistics. This visitor did not wander here blindly. It arrived through a corridor so narrow that chance alone strains to explain it. It threaded alignments that simulation insists should rarely occur. It chose or appeared to choose moments when observation was weakest, and all the while the sphere did not drift. It moved as if following a path known long before it crossed ours. Inside the Pentagon, the corridors of classification absorb anomalies, the way deep ocean trenches absorb light completely silently, without promise of return. Long before the public learned the name 3 Atlas, before amateurs posted their first green sphere images, the object had already triggered quiet alerts across the All-Domain Anomaly Resolution Office, known simply as ARO. The threshold for such attention is low anything interstellar, anything displaying unusual kinematics, anything capable of intersecting Earth's orbit. Yet in this case, the attention did not fade after a brief first glance. Instead, it intensified. Internal logs, which would later leak in faint whispers through unofficial channels, showed a rapid escalation of interagency coordination. Analysts from the Pentagon, NASA, and the intelligence community pulled observational data into cross-domain repositories, normally reserved for unidentified aerial phenomena. The object's classification was never officially altered, but the pattern of interest spoke louder than labels. This was something to be watched, and it was watched obsessively until the moment the sphere appeared. That was when the silence began. Early reports flagged anomalies, the first deviations in the trajectory, the subtle non-gravitational acceleration, the peculiar stability of its coma. Analysts were instructed to prepare internal briefs. ARO staff drafted communication packets to coordinate with NASA's Planetary Defense Coordination Office. Yet something shifted after the late October blackout, when the object disappeared behind the sun and emerged again transformed. What had been a steady current of data sharing slowed to a trickle. Meeting summaries shortened. Divergence reports went missing from the usual circulation channels. By mid-November, ARO's public posture had changed completely. In a statement to reporters, their spokesperson asserted that the object had been assessed as a natural comet, and therefore fell outside the scope of their mandate. No elaboration, no details, no mention of the earlier internal alerts, the flagged anomalies, or the extraordinary orbital deviations now being verified by independent astrophysicists. A quiet retreat veiled in bureaucratic language. This was not unusual behaviour for ARO, an office repeatedly caught between scientific transparency and national security imperatives, but the timing left many uneasy. NASA, when pressed about the collaboration, offered carefully measured replies. They confirmed data sharing but declined to clarify whether ARO had contributed to the delayed release of the high-rise images. Officials spoke in a tone that communicated caution rather than openness. The political pressure from congressional offices only deepened the shadows. Representative Luna's inquiry forced NASA into a closed-door briefing, but ARO did not attend. Nor did they issue supplemental notes, nor did they clarify whether their assessment had changed internally despite their public statement. The agency appeared to shrink from view, its earlier interest collapsing behind a wall of procedural insulation. Scientists watching from the outside recognized the pattern. Early engagement, rapid escalation, then sudden withdrawal, once the questions grew too complex and too public. This is the rhythm of institutional caution. When the narrative threatens to drift beyond familiar frameworks, the safest action is silence. Yet silence itself becomes a signal. The absence of commentary from national security circles left astrophysicists to confront the data alone. Their models showed acceleration that should not be present. Their images revealed a surface too stable for natural processes. Their simulations mapped an orbit threading improbabilities like beads on a string. And still, ARO maintained its quiet stance, not their mandate, not their concern. But this was never about jurisdiction. The object's behaviour did not fall neatly into any category, neither a threat nor a meteor nor a spacecraft nor a piece of debris. It existed in the liminal space where scientific curiosity and national oversight converge. And institutions built to manage the unusual often falter when faced with something unprecedented. Inside NASA, the discomfort was growing. Engineers whispered about the high-rise delay. Analysts wondered why the raw telemetry remained inaccessible. A few hinted that early drafts of internal memos described the object as behaviourally atypical, though that language never survived official publication. What remained was a vacuum, one not of science, but of narrative control. For decades, the public and scientific community have accepted that the Pentagon rarely comments on unknowns until they are fully understood. But in this case, the retreat came precisely when understanding slipped out of reach. As the sphere's transformation spread through scientific circles, the need for open dialogue increased, yet the official voices grew fewer. Each agency pointed quietly toward the other, the burden of explanation passed like an ember no one wanted to hold. And in the end, the silence became indistinguishable from the anomaly. ARO had begun with deep interest and ended with avoidance. NASA had begun with promises of collaboration and ended with staggered incomplete disclosures. Between them lay a trail of unanswered questions. Why were the clearest images delayed? What changed in the assessments after the perihelion blackout? What was discussed behind closed doors? Why does an object deemed natural continue to defy natural models? Scientists do not fear the unknown, but they fear the absence of honest inquiry. By November, the sphere no longer stood alone as a mystery. It had become the centre of a widening circle, science, politics and security, all orbiting an object whose behaviour defied the categories needed to contain it. And as agencies stepped back into silence, the responsibility to interpret the evidence fell to independent observers whose questions only grew sharper. For the sphere was still there, drifting in perfect silence, obeying rules no one had written. And the institutions built to explain the sky had fallen quiet precisely when the sky began to speak. Long before the word probe entered late-night conversations, long before rumours of intention began to creep into public discourse, one scientist stepped into the widening silence with something more disciplined than speculation: a list, a dossier, a sequence of quantified improbabilities that refused to sit quietly inside the statistical margins where anomalies usually fade. Avi Loeb had been here before, standing at the fault line where observation cracks open the assumptions of an older astronomy. But this time he did not offer a hypothesis. He offered accounting. 12 anomalies, each measurable, each stubborn, each resistant to dismissal. Together they formed a structure of doubt more solid than any theory could provide. He began with the simplest point, the non-gravitational acceleration. A push measurable across thousands of observations, consistent across instruments, separated by continents and oceans. A push that could not be erased from any orbital model without causing the predicted path to deviate dramatically from the observed reality. This acceleration, subtle, persistent, inexplicable, formed the backbone of the dossier. The second anomaly followed naturally the absence of visible mass loss. If the object was accelerating due to jets, it must be shedding material. But the images Hubble high-rise stereo ground-based telescopes showed nothing. No plume, no dust, no coma, no faint smearing at the margins. The exhaust required for the observed acceleration simply did not exist in any spectrum. Third morphological transformation. Before perihelion 3I, Atlas behaved like any energetic comet, volatile, asymmetrical, textured with faint jets. After perihelion, it returned as a perfect sphere, smooth and uniform in brightness. No natural mechanism could account for that abrupt shift, especially under solar heating that should have maximized chaos, not eradicated it. Fourth stability. The orb did not flicker, did not fracture, did not bloom into a halo of dust. Across exposure after exposure, surface brightness varied by less than 3%, an impossible serenity for a body emerging from the sun's violence. Fifth directional coherence. The anomalous acceleration pointed consistently without the modulation expected from a spinning comet. If the object rotated and pre-perihelion data strongly suggested it did, any jets would have shifted orientation over time, but the force remained stable. Sixth statistical improbability of the orbit. Harvard's simulations placed the object's approach corridor at 5 in 100,000. ESA found even lower probabilities. The object had entered along the planetary plane instead of from the random orientations expected of interstellar traffic. Seventh, the planetary thread. A near-Mars pass, a Venusian brush, a drift near Jupiter's influence, 3 gravitational corridors navigated in sequence. Natural, yes, but unlikely. And unlikely is where science must begin to ask harder questions. Eighth, the blackout transformation. Everything changed when the object sat behind the sun, timed perfectly, with the moment when no Earth-linked instrument could observe it. Whether coincidental or consequential, the alignment mattered. Ninth, thermal behavior. The sphere should have fractured under the intense solar heating, especially if composed of volatile ices. Instead, it emerged more pristine than it entered. 10th, reflective profile. Photometric analysis revealed a surface that scattered light more like a hard, uniform shell than a porous dust cloud. It mirrored properties closer to smooth regolith or metallic sheen than to sublimating ice. 11th, rotational ambiguity. The brightness curves from July suggested a rotation period near 16 hours, but post-perihelion data showed no periodicity, no modulation, no wobble, no variation. Either rotation had ceased unlikely, or the object's symmetry had become so perfect that rotation produced no detectable signature. 12th, the anti-tail. A stubborn, persistent feature that defied easy explanation, suggesting a dust structure that should not exist in tandem with a spherical, jetless body. Avi Loeb did not present these anomalies as proof of anything. He did not assign intention. He did not argue for design. Instead, he pointed to the silence inside official statements, the absence of explanation from institutions now retreating behind protocol, and claimed that the burden of proof had shifted. It was not enough, he argued, to declare the object a comet. A comet must behave like one. This one did not. His dossier did not break physics. It merely insisted that physics be applied honestly. Each anomaly was testable. Each was falsifiable. Each could in principle be explained by natural means if those means could be identified. But none had been. His call to action was simple and scientific. Watch the object on December 19th. Observe it when it nears its closest approach. Measure everything. Let the data speak where institutions no longer would. He proposed a checklist trajectory deviation. Brightness shift, jet reappearance, surface fragmentation, spectral anomalies, any hint of controlled maneuvering, any deviation from the predicted hyperbolic escape. If the object adhered to its expected path, perhaps the dossier would shrink into the statistical noise of an extraordinary but natural wanderer. But if it did not, if even one parameter slipped away from gravitational prediction, then the mystery would deepen beyond the boundary of reasonable doubt. Scientists across the world read the dossier and felt the tension it carried. Not sensationalism, not fear, simply the weight of evidence. 12 anomalies do not make a conclusion, but they do make a question. And that question now hung in the air as silent and immovable as the sphere itself. If it is only a comet, why does everything it does refuse to behave like one? Long before any official observatory had the chance to recover its breath, a new whisper began seeping through astronomy forums, Discord groups, and private message threads, with the slow viral persistence of a rumour that did not quite dare to name itself. It arrived in fragments, a cropped image here, a stretched histogram there, a breathless caption, claiming something seen in the corner of a long exposure stack. Not one object, the whispers said. Several. Small spheres glowing smooth and eerily similar, moving in silent attendance near 3i Atlas. No data-backed paper ever claimed their existence. No professional observatory logged multiple intruders. But whispers thrive in vacancies, and this mystery had left vacancies large enough to echo. The sphere had emerged flawless from a blackout behind the sun, its acceleration unexplained, its geometry unnatural. Into that vacuum of clarity speculation found fertile ground. The first companion orb images surfaced anonymously blurred features beside the main sphere, faint points of greenish light arranged in what some insisted was a formation. But nothing in those frames withstood scrutiny. The backgrounds didn't align. The timestamps conflicted. Pixel noise masqueraded as structure. Those who knew how to read FITS files dismissed the claims without hesitation. Still the rumours did not die. They changed shape like dust disturbed by an unseen current. A user from Brazil claimed to have captured 2 faint flares matching the main object's spectral signature, but his calibration frames were missing, rendering the claim unverifiable. A Discord thread in a major astrophotography community circulated a long exposure pass that allegedly showed 4 spheres in a diamond configuration. It was later revealed to be noise amplified by aggressive contrast stretching. A Reddit post deleted within minutes spoke of synchronized drift in 3 small lights near the comet's path. To the trained eye, each case unraveled quickly. To the untrained eye, they accumulated. It was not evidence of companions. It was evidence of hunger, humanity's old reflex to populate mysteries with more mysteries. Yet the rumour persisted because it was built not on data but on the void surrounding it. The high-rise images, delayed for reasons never fully explained, had sharpened public suspicion. The hidden perihelion blackout had carved a narrative gap perfectly shaped for speculation. And the orb's impossible symmetry, its refusal to behave like anything natural, invited questions no one could answer. In that climate, even absurd claims found purchase. Still beneath the noise, a more disciplined puzzle formed. Why were so many observers convinced they were seeing more than one sphere? The psychological explanation felt too simple. The human brain seeks patterns, mirrors, repetitions. But in high-fidelity astrophotography communities populated by people who daily wrestle with calibration frames, flat field corrections, arc seconds, and spectral filters, wishful thinking alone rarely fuels widespread speculation. Some analysts noted that in certain long exposures, faint diffraction artifacts near bright stars could, when contrast was abused, resemble small orb-like glows. Others pointed out that the sudden emergence of a sphere with no coma, no tail, and no rotational flicker made it unusually easy to mistake background noise for structure. Still others suggested that lingering distrust stirred by the Pentagon's reticence and NASA's delays had primed the community to assume concealment. But there was a deeper, quieter reason the rumours persisted. The object encouraged symmetry. Its perfect shape subconsciously invited the idea that it might not be singular. Its unvarying glow suggested reproducibility. Its silence suggested fleetness. Its orbital improbabilities suggested coordination. In the mind's shadowed corners where imagination and mathematics collide, the idea of multiple spheres seemed to fit the broader arc better than the notion of a lone anomaly drifting through emptiness. Yet science demands discipline, and discipline demanded the truth. There was no verified evidence of companion objects, no time-stamped FITS files, no photometric matches, no astrometric clusters. The data simply did not show what the rumours craved. Still one faint thread remained. ESA's JUICE spacecraft. Its cameras pointed not toward Jupiter, but toward the deep sky during a rare idle sequence, had taken exposures in November. These frames were scheduled for downlink months later, delayed by the vast distances and transmission protocols required for deep space data. European mission scientists quietly acknowledged that the images would include the region surrounding 3I Atlas's path. Whether they would show anything more than background stars remained unknown, and so the rumour of companion spheres shifted from assertion to anticipation. If they exist, JUICE may see them. If they don't, JUICE may prove their absence definitively. Until then, the idea hangs suspended, not debunked, not confirmed, simply unanswered. In the meantime, the main sphere continues its silent journey solitary and unaltered. It neither acknowledges nor denies the rumours spun around it. It drifts through the solar system untouched by speculation, its smooth shell giving away nothing. Perhaps there was never more than one. Perhaps the sky itself is teaching us restraint. For now, the companions remain phantom shadows cast by fear, wonder, and a mystery that refuses to shrink. But in the absence of data, even shadows demand patience. Because until a real instrument captures proof, science stands firm. There is one orb, only one, and even that single sphere already strains the imagination to its limit. As December approached, anticipation tightened across the scientific world with a gravity all its own. For months, 3I Atlas had moved through the solar system, like a riddle wrapped in silence, accelerating without shedding mass, smoothing itself into an impossible sphere, and slipping through corridors of probability so narrow they resembled intention more than chance. But December 19th, its closest approach to Earth promised something different clarity, not because the object would suddenly reveal itself, but because for the first time since its transformation it would no longer be able to hide. Astronomers marked the date in red on their calendars, not metaphorically, literally. In observatories across Chile, Spain, Hawaii, Australia and the Canary Islands, schedules were rearranged, proposals rewritten, and entire research nights reallocated. Every major instrument capable of tracking the object had secured time. The global scientific community had moved in quiet synchronization, and the message behind their coordination was unmistakable. Whatever 3I Atlas is, the sky will no longer protect it. In the weeks leading to the encounter, ground-based telescopes struggled against winter storms, atmospheric turbulence and the object's faintness. Yet each night pushed it closer, brightening incrementally, revealing subtler details in its light curve, inviting deeper scrutiny. The James Webb Space Telescope, too distant to swing casually toward a moving target, had nonetheless prepared emergency observation protocols, the kind reserved for catastrophic supernovae or unexpected gravitational lensing events. Hubble's team created contingency modes. Even survey instruments that rarely abandon their broad sky sweeps, such as Pan-STARRS and Atlas itself, planned targeted sessions, abandoning routine cadence in favour of the anomaly racing toward its moment of truth. For the first time since July, since before the blackout behind the sun, since before the transformation into a flawless orb, the world's eyes would converge on a single point in space at the same time. And with that convergence came opportunity. On December 19th, the object would be 8 astronomical units away, close enough for high-resolution imaging, close enough for deep spectrum analysis, close enough to measure the subtlest deviations in its predicted hyperbolic escape. Its brightness, though modest, would finally be strong enough to resolve features smaller than the uncertainty margins that had plagued earlier sightings. If the sphere flickered, telescopes would capture it. If it shed particles, spectrometers would detect them. If it altered course, the deviation would be obvious within hours. Unlike perihelion, this moment provided no hiding place, no solar glare, no geometric blind spots. As the Earth rotated, observatories across its surface would hand off the target to one another in a continuous chain, creating a nearly uninterrupted 24-hour surveillance window. And the stakes could not have been higher. The theoretical possibilities were stark and mutually exclusive. The object behaves exactly like a natural comet. It follows its predicted trajectory, dimming slowly as it recedes. No unexpected thrust, no brightness surges, no structural changes. If so, the anomalies might find mundane explanations in the autopsy of hindsight. The object deviates, even slightly. A curve where there should be a straight line, a brightness spike inconsistent with sublimation, a jet with no rotational modulation, or a silence broken by motion that does not belong to gravity alone. And should the latter occur even subtly, it would confirm that the puzzle was not an illusion of statistical noise or observational bias. It would confirm that the sphere's behaviour was ongoing, active, real. Scientists prepared in advance for every scenario. Teams developed algorithms to compare live astrometric data with predicted ephemerides in real time. Others built pipelines to detect faint, short-lived jets that might flare for minutes, not hours. Radio observatories pre-configured search bands not to listen for artificial signals, but to capture any change in the sphere's interaction with solar radiation. But the most sobering preparation happened within mission control rooms of spacecraft far from Earth. NASA's Juno probe orbiting Jupiter adjusted its observation schedule for the coming March, on the chance however remote that 3i Atlas might pass through a region Juno could monitor. This was not standard procedure. Missions rarely alter long-term plans for transient visitors. Yet Juno's team understood what was at stake. If the object changed direction even subtly, its future path might intersect regions of space where only deep space probes could observe it. Even more quietly, ESA's JUICE spacecraft updated its long-exposure queue. Weeks earlier, its operators fully aware that the data now crossing interplanetary distances would not reach Earth until February. Its November captures might prove irrelevant or invaluable. The entire solar system seemed to lean in, and beneath all the technical readiness lay a deeper tension, a philosophical tremor shared by scientists who would never voice it publicly. In the natural world, mysteries dissolve under measurement. In the realm of the unknown, some mysteries deepen. December 19th would reveal which realm the sphere belonged to. If its acceleration was driven by sublimation, it would appear. If its symmetry resulted from unusual chemistry, spectra would show it. If its quiet precision was nothing more than coincidence, the orbit would settle into predictability. But if none of these happened, if the sphere continued its journey unchanged, accelerating without visible cause, navigating with improbable precision, then humanity would face a truth far more unsettling than discovery. Not all arrivals announce themselves. Not all visitors behave like debris. Not all mysteries are meant to drift away. On December 19th, the object would make its next move, and for once every eye on Earth and beyond would be watching. By the time the sphere approached its December window, scientists found themselves confronting a truth both exhilarating and disquieting. Nature was no longer behaving like the nature they knew. In the long tradition of astronomy, every anomaly, every flicker, every deviation, every unexpected turn eventually bowed to explanation. A new equation, a new model, a new insight, order restored. But 3i Atlas did not bow. It did not bend toward comprehension. Instead, it moved with a strange composure, a quiet sense of direction that unsettled even the most disciplined minds. In the meetings and observatory control rooms where data from the object was analysed, a single phrase began to echo, not officially, not in papers, not in memos, but in the hushed conversations that happen when the lights dim and the telescopes hum through the cold hours. It acts as though it knows. No one meant intention, not directly. They meant coherence behaviour too consistent to be random, too stable to be chaotic, too smooth to fit the rough machinery of cometary physics. It was not the presence of answers that unsettled them, but the presence of patterns where none should exist. Astronomy is shaped by drift. Dust drifting from the nucleus, jets drifting with rotation, orbits drifting under gravitational tides. Drift is nature's handwriting. But the sphere refused to drift, not in light curve, not in structure, not in trajectory. Its form held constant across weeks of observation. Its path deviated from pure gravity, yet did so without the erratic fingerprints of natural outgassing. Its brightness remained uniform, its behaviour paced its movement paradoxically stable even as it accelerated. It obeyed physics only selectively, as though following the rules that suited it and ignoring the rest. Scientists attempted to articulate the contradiction with care. Some called it anomalous persistence. Others classified it under non-chaotic morphological stability. But beneath the vocabulary lay a deeper discomfort. The sphere behaved more like a system than an object, more like a structure maintaining itself than a fragment weathering its inevitable decay. In nature, entropy rules. Structures degrade, heat scatters, symmetry breaks. But here was a body that resisted those tendencies, holding itself together with a precision that appeared to counteract the very forces meant to unravel it. High-resolution imagery only deepened the unease. The surface reflected light with a uniformity inconsistent with terrain or texture. No cold regions, no hot regions, no roughness. The brightness profile resembled an engineered curvature, not a porous tumbling relic from deep space. Even stranger, its reflectance stayed consistent regardless of orientation, suggesting a sphere that did not care which face the sun struck, as though its composition or design redistributed heat evenly. The possibility hung unspoken. Could a natural object maintain perfect symmetry under solar heating without rotating, cracking, or shedding mass? Every model said no. Observers tracked micro-brightness variations, hoping to detect rotation. If rotation existed, it was too slow or too subtle to imprint itself on the light curve. Yet if the sphere was stationary relative to itself, thermal stress should have fractured it long ago. Something was balancing those stresses. Something was stabilizing the acceleration. Something was holding the shape intact. Theory stretched thin, trying to match the observations. Some astrophysicists proposed exotic materials, ultra-dense aggregates of interstellar ices, or metallized compounds capable of resisting decay. But spectroscopy showed nothing metallic. Others invoked magnetic cohesion, suggesting a plasma envelope that concealed internal structure. Yet no magnetic signatures appeared. A few dared to suggest a hollow structure, but the orbital mechanics did not match a hollow object, would respond differently to solar radiation pressure drifting outward more rapidly. This one accelerated sunward. Still others proposed a fractal architecture, microscopic lattices that behaved as a single macroscopic shell. But even such a lattice could not account for the absence of thermal variation or the consistency of the surface brightness. One idea remained spoken reluctantly. Self-regulation, not biological, not technological, simply systemic, a structure capable of maintaining equilibrium. Whether natural or unnatural, this concept carried weight. Certain exotic crystals self-regulate internal stresses. Some molecular formations maintain geometric perfection under external forces. But none had ever been observed at the scale of a cometary body. Yet here was the sphere resisting entropy with a poise that felt almost intentional. The object's orbital behavior magnified the tension. The acceleration remained constant and directional, ignoring rotational modulation. This alone implied one of two possibilities. The object had ceased rotating, altogether unprecedented for a comet-sized body under solar torque, or the force causing the acceleration was internal, unaffected by rotation, because the entire structure moved as one controlled unit. The second possibility whispered through scientific discussions like a draft through a closed room, not because it was preferred, but because it was the only one that fit, and still the sphere offered no sign of propulsion, no vent, no flare. No artifact that could explain the thrust. It glided through space with the serenity of something at peace with its environment, something that had found a way to exist without fraying against the forces around it. Scientists stared at the object and felt the ground of certainty shifting beneath them, not toward fantasy, but toward a deeper form of realism, one that acknowledged that nature may build structures we simply do not yet understand. For centuries, humanity believed the heavens were ruled by perfect circles, until observation shattered the illusion. Now a perfect circle returned, not theoretical but real, and once again the sky asked whether humanity's understanding was too small to contain it. The sphere did not drift. It maintained, it adapted, it persisted, and the question grew sharper with every passing day. If nature forged such a thing, what deeper laws has nature kept hidden from us? If it did not, then what waits in the silence between the stars? By the final weeks of December, as the sphere continued its immaculate glide through the solar system, the mystery that had begun as an astronomical anomaly evolved into something far more intimate an encounter, not with an object, but with the limits of human understanding. Scientists found themselves returning again and again to the same question, phrased differently each time but carrying a single quiet weight. What does it mean when something in the sky refuses to drift? For drifting is the signature of the cosmos. Stars drift across the galactic tide. Dust drifts from ancient collisions. Comets drift through the gravitational weave. Even planets, steady as they seem, precess and wobble through the ages. Drift is not mere motion. It is the universe's way of reminding every object that nothing remains unchanged. And yet this sphere did. Perfectly. Patiently. As though anchored not by gravity but by its own internal logic. For astronomers, this steadfastness felt uncanny. But for philosophers, poets, and anyone who had ever stared upward to seek meaning, the sphere's refusal to decay carried a different resonance. It suggested a kind of resilience foreign to the natural world, a steadiness that evoked intention even when science did not dare speak it aloud. As data accumulated, the object's paradoxes grew sharper. Instruments registered no loss of mass, yet the orbit demanded a force. High-resolution images showed no fractures yet. Perihelion heat should have torn it apart. Its path through the solar system read like a navigational thread, yet randomness insisted it should have arrived from any direction but this one. Across radio observatories and optical telescopes, across graduate classrooms and cosmic dust research labs, a single private thought began to surface in minds that did not normally entertain such possibilities. If the sphere is not obeying nature, then it is obeying something. This did not require technology or intelligence. It required only coherence patterns deeper than chance behaviors, more stable than chaos. And 3i Atlas displayed coherence in ways the universe rarely grants. Its silence was not absence. Its symmetry was not coincidence. Its stability was not luck. The cosmos is full of loud mysteries, gamma-ray bursts screaming across space-time supernovae lighting up the darkness, quasars roaring from galactic hearts. But this anomaly was quiet. Its truth hid not in brilliance or violence, but in stillness, a stillness that stared back. For humanity, the emotional impact of this realization unfolded gradually, not through sensational headlines or speculative documentaries, but through a slow, collective exhale across the scientific world. Researchers who had spent their lives reducing the universe to equations felt for the first time in years the presence of something that did not shrink under analysis, something that widened with every measurement, something that stared back with the kind of calm that forces introspection. The sphere became a mirror that reflected not our knowledge but our uncertainty, a reminder that the universe does not owe us simplicity, that the laws we trust may not be complete, that the cosmos, patient and ancient, still cradles secrets too deep for our current mathematics to reach. Humanity once believed the Earth was the center of the universe, then it believed the sun was, then the galaxy, then the observable cosmos. But each revelation has pushed the boundary of our humility further outward. Now a single silent orb drifting through our solar system, refusing to behave as nature requires, pushes that boundary again. For if the sphere is natural, then nature is far stranger and more beautiful than we imagined. And if it is not natural, then we are no longer alone in a universe that has finally chosen to whisper back. Either way, the meaning is profound, because the object does not drift. And perhaps neither will the question it leaves behind. The sphere continues its slow departure, now faint against the darkness, a quiet ember moving beyond the cradle of our instruments. And as its light thins into the distance, the urgency that once surrounded it fades into something softer, more contemplative. The sky returns to its familiar rhythm, patient stars, slow planets, clouds of dust drifting as they always have, and yet the night feels changed, not in the way a storm changes a landscape, but in the way a whisper changes a dream. For months the object drew our attention like a held breath. We tracked it, questioned it, struggled to place it within the comfortable boundaries of known physics. But now, with its shrinking glow resting gently at the edge of detection, the universe invites us to pause, to breathe, to remember that some mysteries do not arrive to frighten or disrupt, but simply to remind us how vast the unseen truly is. Out there between the stars, countless voices move in silence, dust carrying the memory of collisions billions of years old, comets wandering paths older than life on Earth, light travelling from galaxies we will never reach, and perhaps among those quiet travellers shapes and structures we have not yet learned to recognise. The sphere was one such traveller, a reminder that not everything is meant to be understood at first contact. Some things enter our awareness only to expand it, to stir a question, to plant a seed of wonder that grows slowly across a lifetime. As its faint glow fades, let your gaze soften. Let the edges of thought widen. Allow the night to settle around you like a gentle tide. For the universe is not asking you to solve it tonight, only to rest in its presence. And in that presence, sleep comes softly. Sweet dreams.